Once more, good morning, students. Welcome to class. As usual, I'm your host, Mr. Oyerinde Tunde Daniel. But with me here is also Mr. Aderigbe, who will be taking some segments of this subject. You know, the mode of our meeting are in three phases. We have the Zoom, the YouTube channel, as well as the CBT section. So I will be the one to take you through this YouTube class, and I want you to pay adequate attention as we continue in our class. The topic of our discussion is electricity 2. I call it electricity 2 because we've already had electricity 1. Under that one, we look at definition of electricity. We look at conductors and insulator. We look at the various methods of generating electricity in the lab. We look at examples of conductors, and we'll also look at examples of insulator. In continuation of where we stop, the objectives of this electricity to include to state Ohm's law and use the law to solve problems, state the factor affecting electrical resistance, list the effect of each factor, use electrical resistance formula to solve problems, derive electrical energy and electrical power formula, derive electrical energy and electrical power, define electrical energy and electrical power, as well as state its formula, derive the formula that relates electrical energy and power, and use the respective formula to solve problems. Now, what does Ohm's law means? Ohm's law states that the current flowing through a metallic conductor, e.g. wire, is directly proportional to the potential difference between its end, provided that temperature and other physical conditions of the conductor are constant. Again, Ohm's law states that the current flowing through a metallic conductor is directly proportional to the potential difference across its end, provided that temperature and other physical conditions of the conductor are kept constant. Ohms is defined as a resistance of a conductor when a potential difference of 1 volt applied across its end, current of 1 amp to flow through it. Ohm's law is not obeyed by conductors such as diode, transistor, rectifier, and gases. These are materials that will not obey Ohm's law. Let me rephrase Ohm's law again. Ohm's law states that the current flowing through a metallic conductor, e.g. wire, is directly proportional to the potential difference across its end, provided that temperature and other physical conditions of the conductor are kept constant. And materials that will not obey Ohm's law are transistor, rectifier, diode, and gases. These are examples of material that will not obey Ohm's law. We want to look at ohmic and non-ohmic conductor. Ohmic conductors have a linear relationship between voltage and current, but non-ohmic conductors do not. So when a linear relationship exists between voltage and current, such conductors that exhibit that are called ohmic conductor. If you can see here, we have 4 different graphs. Graph A shows a linear graph, a straight line graph from the origin. Hence, it is called ohmic conductor. But for the other graph, B, C, and D, they are non-ohmic conductor. Also, we want to look at ohmic and non-ohmic resistor. Resistor that obeys Ohm's law. Any resistor that obeys Ohm's law, any increase in voltage creates a linear increase in current. As voltage increases, as current increases, the voltage also increases. Hence, we say that such material is an ohmic resistor, while the one that dock opposite are called non-ohmic resistor. Remember, Ohm's law states mathematically V equals to IR. We are able to look at Ohm's law. We are able to look at material that obeys Ohm's law and those that will not obey Ohm's law. We've discussed ohmic and non-ohmic conductor as well as the graph. So it is important that you should be able to identify the graph that explains Ohm's law. We've also look at ohmic and non-ohmic resistor. Now, what are the factors that are affecting electrical resistor? These factors are the length, the area of the conductor, the temperature of the temperature, as well as type of material. So let's look at the effects of all the materials stated. What is the effect of length? As the length of the material, the longer material have a greater resistance. If you can see, we have two material here. The longer one has a resistance of 2 ohms. So the effect of length is that the longer the material, the greater the resistance. Cross-sectional area of the material. The larger the cross-sectional area, the lesser the resistance. Please, I need you to take this into consideration, because I will definitely ask a question on this. What is the effect of length again? The higher the length, the greater the resistance, and the higher the area, the lower the resistance. What about temperature? The higher the temperature usually result in higher resistance. As the temperature increases, the resistance also increases. Now, the kind of materials. Iron has more electrical resistance than a geometrically similar copper conductor. Now, I want to look at electrical work done in a given circuit. The formula for calculating electrical work done are work done is equal to IVT, work done is equal to I square RT, and work done is equal to V square over R times T, where V is your voltage in volt, R is your resistance in ohm, and T is your time in seconds, and I is our current in amps. Remember, in our last class, we say Q is equals to IT, where Q is the quantity of charges in coulomb, T is our time in seconds, and I is our current. So we are able to derive all these equations from Q equals to IT and also from V equals to IR. So work is done when electricity flow from one point to another of different potential. If I ask you, when is electricity said to perform work? The answer is work is done when electricity flow from one point to another of different potential. This slide also explains the steps involved in deriving the 3 equations I mentioned in the previous slide. Now, electrical power. Electrical power basically is the rate of doing work. So the various formula used in calculating electrical power is just a situation whereby you go to electrical energy and remove the time. For example, P, power, is equals to IV. That is, you omit the time. We've discussed this in our class, in the class, and I've taught you how to derive all these formula. So I don't think it is, we should not waste time on that now. So let's look at electrical power. As I said earlier, when you ask to calculate electrical power, just go back to electrical energy and remove your T. Electrical power is defined as the rate of doing work, and electrical power is just given as mathematically is given as IV, and the unit of power is your watt, but larger units are measured in kilowatt or megawatt. And it is important to know that 1 kilowatt is equal to 1000 watts. Electrical appliances usually have some markings on them indicating their rating in watts and in volts. A mark of 100 watts and 220 volts means that the appliance consumes a power of 100 watts when connected to a circuit which maintains a potential difference of 220 volts across it. It implies that the current required to run the appliances can be obtained from the relation P equals to IV. When you make I the subject, it becomes P over V, and it will give us 0.45 amps. Buying and selling electrical power. 1 kilowatt hour is the electrical energy consumed by an appliance when power of 1 kilowatt is used by the appliance for 1 hour. Please, I read that again. 1 kilowatt hour is electrical energy consumed by an appliance when power of 1 kilowatt is used by the appliance for 1 hour. Now, 1 kilowatt hour is equals to 1 kilowatt hour is equals to 1 kilowatt times 1 hour, which is equivalent to 1000 times 60 times 60. Now, this example here for us to discuss. An electrical appliance takes 5 amps when it's operated on by 220 volts. Find the cost of operating the appliance for 12 hours at 10 kobo per kilowatt hour. Remember, power in this situation, the formula to use is IV. When you do that and substitute all the necessary thing in the equation, it will give us 132. So when we convert it to naira, it will become 1 naira 3.2 kobo. Now at this point, I would like you to take this quiz, writing down in your notebook, when V equals to IR, what will be our I and what will be our R and what will be the power? Again, the relationship between current and power. I want us to fill in all this formula. In our Zoom class, I will call you to explain to me how you arrive at your answer, because these are memorizing and knowing how to derive this formula will help us in solving, or will help you in solving most of the questions that we encounter in this topic. Now let's look at this first question. It says, a technician investigates a light-dependent resistor connected in series with 220 ohm resistor and a voltage source. The technician measured the voltage across the LGR and also the current in the LGR. Which of these circuits should the technician use? We have 4 circuits, A, B, C, and D. The circuit to use in this point is circuit B. Why is this circuit B? In circuit B, you can see that the voltage is connected in parallel, while the voltmeter is connected in parallel, while the ammeter is connected in series. So it is important to note here that for you to use for voltage to work effectively in a circuit, it must be connected in parallel, and your ammeter must be connected in series. Any circuit in which voltage is not connected in parallel and ammeter is not connected in series will not give you the desired result. Hence, it is only in circuit B that we have the required connection. Hence, circuit B is the correct answer. Differentiate between galvanometer and ammeter. Basically, a galvanometer is used to measure small electrical current, while ammeter is used to measure larger electrical current. If you want to measure electrical current in milliampere, it is important that you use a galvanometer and not ammeter. So galvanometer measure small electrical current, while ammeter measure larger electrical current. What is internal resistance? Internal resistance can be defined as the resistance of the cell when it is not supplying any current. It can also be called the loss volt. So another name for internal resistance is what? The loss volt. An internal resistance is often represented with small letter r, while big letter R stands for resistance, while small letter r stands for internal resistance. What is a junction or a node in an electrical circuit? A junction or a node is a point in a circuit where 3 or more connecting wires meet. A point where 3 or more connecting wires meet is called a junction or a node. Now, a Wheatstone bridge. If you can see here, we have 4 resistors, 1, 2, 3, 4. So let's look at the question. What is a Wheatstone bridge? It is a circuit bridge designed by Wheatstone which measure accurately the resistance of a resistor. So to measure accurately the resistance of a resistor, in the lab, we use what we call a Wheatstone bridge. And a Wheatstone bridge comprises of 4 resistors. A potentiometer. This is a diagram of what a potentiometer looks like. So the question says, what is a potentiometer? A potentiometer basically is a device used in measuring and comparing the electromotive force of a cell. Electromotive force is abbreviated as EMF. So the EMF of a cell is basically measured using a potentiometer. The instrument used for measuring potential difference is known as the voltmeter. So a voltmeter basically is used for measuring potential difference. The electrical energy supplied by Lenchen cell is obtained from, is it mechanical energy, chemical energy, solar energy, or magnetic energy? Basically, it is obtained from chemical energy. In photocell, light energy is converted into kinetic energy, heat energy, chemical energy, or electrical energy. So in photocell, light energy is usually converted into electrical energy. Question again, what is a cell? A cell basically is a device for converting chemical energy into electrical energy. The device for converting chemical energy into electrical energy is called a cell. The next question says, what are the two ways cell and resistance can be arranged in a circuit? Cell and resistance can be arranged in series or parallel. The unit of resistance is called what? This is a question. The unit of resistance is called ohms. A group of cells is called what? A group of cells basically is called a battery. This is a multiple choice question. Out of the following, which is an insulating material? Copper, gold, silver, and paper. The answer is paper. Paper is an insulating material, while gold, copper, and silver are conducting material. The resistance of a conductor varies inversely as the length, area of cross-sectional, temperature, and resistivity. Basically, it varies as area of cross-sectional area. With rise in temperature, resistance of pure metal does what? Increase, decreases, decreases, first increase and later decrease, remain constant. The answer is increases. Which is the best conductor of electricity? Iron, silver, copper, and carbon. The answer is silver. And this is a classwork again for you, which I will ask you to explain how you arrive at your answer in our Zoom lesson. At this point in time, I want to say thank you for your time. If you have any question as usual, please send it through the school portal, address it to me directly, or send it as attachment and send it to me through my email address. I must commend Okonko, as he has been the only one that has submitted his assignment to me via email. I want to believe that we've all attempted the assignment. Thank you for your time. God bless you all. Thank you.